and to present them on a graph. Chapter 3, we are going to learn how to summarize data. Summarize data means finding values that could summarize the information from the data. Those values are generally the values that are averages, that is like the middle, the center, a point of reference from which we could determine how the other values are behaving. And we also have variations. Measure variations help us to determine the variability of the data that we collected. That also helps us to know how to measure how away we can be from the center. Those are the two essential things we want to learn here in chapter 3. So when we are dealing with so many decisions, we may want to know if the decision was good or bad according to some point of reference. If you take a test, you might want to know how good your score is with reference to a point. If there was a way for you to know the average performance of the class, you could use it to determine if you are below or above average. If you get your score maybe of a B, someone can tell you most people had C, and that can also help you to determine that you are better than most people. In some instances, we may also use what we call the median. For example, if you want to buy a house or a car or determine your average salary, you might not want to take the average salary of everybody that has a first degree, because some of them could exceptionally do so well that they can start at $100,000. And then you might feel like, oh, if I don't get 80,000, I will not get a job. I will not accept the job. And then you spend so much time thinking that you must have that high salary. But another measure that is useful is the median. When you listen to TV, sometimes you will hear the median income. The median is the middle, which sometimes is useful because it gives you the impression of where the center is. We may want to talk about the median salary. So the median cost of housing. So those are three commonly used measures of central tendency. The average that you are used to, which consists of adding everything and divide by the total. The most frequent value, which we call the mode. For example, if you go to a store and you want to buy maybe a shoe to a guy that you don't really know his size, you may ask, what is the average shoe size of men? This person you are talking to might not be able to get all the men size and take the total and divide. What he or she will tell you is the commonly purchased shoe size in the store, which is what we call the mode, the most frequent value. So the mode is the data value that occur the most. As we were making frequency distribution table, you can easily identify the mode by looking at the frequency that is the highest. The category or the value associated with that is the mode. In some cases, you can have more than one mode. You can have two modes. And we say that the distribution is bimodal. If you have more than two modes, it is multimodal. But at a certain point, when almost all the values have the same frequency, we will just say there is no mode. If you are dealing with group data, we will call it the modal class. That is the class with the highest frequency. The last time we had a class with 21 value, that class was the modal class. So this is an example. What I did in this example is an easy way to get data. I just count the number of letters in each of the words of this sentence. So the first word is count. We have C-O-U-N-T, 5. That's the first value, 5. The T-H-E, that's the second value, 3. Letters, L-E-T-T-E-R-S. This is correct data collection. So these are the numbers of letters used to write each of the words of the sentence, count the letter in each word of this sentence, and give the mode. So what is the mode? Yes. The mode is 4, is that correct? The mode is 4, that is most letters in this sentence, the number of letters in this sentence that is the highest has not the highest number of letters. The letter that comes, the number of letters that come more often is 4. So 4 is the mode. So the mode is an easy value to obtain. If you have a frequency distribution table, just look at the frequency and see which one has the highest frequency. The median is the middle of the arranged data. To get the median, you arrange data in order and identify the middle, the midway. If you know the number of values that are in the data set, you can determine the position rank of the median by, if you have n values, just do n plus 1 divided by 2. If n was odd, you will have an exact value. If n is even, you will have a decimal. That decimal indicates that you will take the average of the two values that are in the middle. We are going to look at some examples. What do barbecue flavor potato chips cost? According to Consumer Report, the prices per ounce in cents of the weighted chips are given. Find the median. To find the median, we will first arrange the values in order. And there will be two values that are in the middle, 19 and 27. We take the average of those two, and that will be the median. Naturally, if you have an even number of values, you will not find one value at the middle. If you have an odd number of values, there will be one value at the middle. So, for example, if we consider this data, we can easily find one value, yes. Okay, thank you. So this is an example of an odd number of values. When they are odd, one will be at the middle. We have here. Generally, we use Excel to get all of this, or your calculator. We are going to learn how to use calculator and how to use Excel to get those values. But we want to know what those values are first. So the arithmetic mean is another average, which is the most used average because you can manipulate it as a number. You add all the values and divide it by the total. You get the arithmetic. The arithmetic means has some issues in the sense that we can have outliers. What we call outliers are very few extremely large or extremely small numbers that will affect the meaning of the arithmetic mean. So suppose we want to calculate the grade of Linda that needs to be in biology. She did not do very well on her first 3 tests. However, she did well on the last 4. Here are her score. Compute the mean and determine if Linda grade will be a B, that is between 80 and 89, or a C between 70 and 79. So you will add all those 7 values and divide by 7. We have 80, which is just a B. So to compute the mean, you add all the values and divide by the total. So the sample mean is generally represented by X bar and the population mean by the Greek letter mu. We use the sign. This is sigma in Greek, is to mean sum. Now we write like this, it means sum of the X values. So here we will see that X bar, the sample mean, is the sum of all the X, the values, add them, including multiplicity, and divide by the sample size n. The population mean is denoted by the Greek letter mu. So mu is a parameter and X bar is a statistic. We say that values from the sample are called statistic, value from the population are called parameters. So mu is a parameter. We usually use Greek letters for parameter and English letters for samples. So far we have learned about 3 types of measures of central tendency: the mode, the median, and the mean. The main objective of the measure of central tendency is to have an idea of the middle, of the average, of the center. So in some cases, the mode can be useful. But the problem with the mode is that we cannot really manipulate it arithmetically. So the median comes in and is at the middle. The median is good, but sometimes it is not that informative, depending on the nature of the data you have, because you can add many values to it and it still remains the median. If I add one value at the bottom end and another value at the top end, the median will remain the same. So that's one of the weaknesses of the median, which is also a weakness of the mean, the arithmetic mean, because if you have suppose you want to decide whether you will move into a city and you randomly ask 5 people about the cost of their houses. One might tell you that his house is 35,000. Another one, 47,000. Another one, 38,000. Another one, 43,000. Another one tells you that his house is 300,000. If you take the arithmetic mean of these 5 numbers, you will have the impression that the cost of living in this city is very high. You understand what I mean here? Because of that 300,000. But if you want to take the mode, two people will have exactly the same cost of their house. So there will be no mode, for example. Then you will think about the median. To find the median, we will arrange the values in order: 35,000, 38,000, 43,000, 47,000, and 300,000. So the median is 43,000. That gives us a better sense of the average cost of housing in the area. So the arithmetic means is good because we can manipulate it mathematically, but most of the time it is affected by those values that we call outliers. And in some cases, we use what we call a trimmed mean. A trimmed mean is the mean in which you trim the ends. So when we suspect that they are outliers, we can trim the tails, the ends of the values to get rid of those outliers. We may assume that, for example, the outliers are the bottom 5% and the top 5% of the data. And then we'll say we will find a 5% trimmed mean. How do we find the 5% of the data set? You multiply the sample size by 5 divided by 100. For example, if you have 20 values, n equals to 20, 20 times 5 divided by 100. What does it give us? 20 times 5 divided by 100. It's just like 2 times 5 divided by 10. 1. So we are going to take away the first value and the last value and take the mean of the middle 18 values. So when you are asked to print, you want to know how many number you want to take away from the bottom and the top. If you have n equals to 30, then 30 times 5 divided by 100, 1.5. We round it up to 2. Meaning we will take the last 2 down and the top 2. So we'll be left with the middle 26 value. So sometimes you may have to deal with trimmed mean. So that means you want to cut off the values, some values to the top and to the bottom. So some of those classical distributions are the symmetric, skewed to the left and skewed to the right. So we want to know how the measure of central tendencies behave in each of these distributions. For a symmetric distribution, the mean, the mode, and the median are the same. All the measures of central tendencies are the same. You will see that we will always prefer to deal with a symmetric distribution, which later on we are going to generalize it more to a normal distribution. It has the advantage that we are not going to be fighting over which measure of central tendency to use, because they are all the same. When a distribution is skewed to the left, skewed to the left means most values are to the right. So naturally, the mode will be at the right. And the way we arrange values is from left to right, from lowest to highest. So the mode will be the highest of those 3 measures. If the distribution is skewed to the left, the mode goes to the right. So it becomes the highest of the 3 measures. The median is always at the middle. Okay? The median is the middle, so it is always at the middle. So the arrangement will be mean, median, mode for a distribution that is skewed to the left. The 2 values that will change is the mode and the median. So when the distribution is skewed to the right, the mode comes to the left because most values are to the left. So the mode will become the smallest of the values of the 3 measures, followed by the median and then the mean. So sometimes when you take online class, those are the type of question I ask. Sometimes I don't ask that in the regular test here, but it's good to know. So in some cases, information about the data are not given in a way that all the values have the same weight. Like when we were computing the grades of Linda, we assume that each test score has the same value. Do you understand what I mean here? So for that, we just add and divide. But in some cases, values we obtain might have different weights. Some professors might tell you that homework will count for 10%. Quizzes will count for 20%. Exam will count for 70%. If he's scoring everything over the same amount, either 20 or 100, you may not always be adding your values like that. I used to do that before. And I did not really care how much points you should have for your homework, how much points you should have for your quiz, how much points you should have for. Because at the end, I will use a proportion, a weight values in statistics. So homework used to be 10 points. Take-home problems used to be 20 and for each of them. An exam used to be 25. So it was difficult for students to think that take-home problem and exam don't have the same weight. Because I will give 10 take-home problems, give 10 homework, and I will give 3 exams. So exams has a higher weight, but it's not perceivable because each time you are taking your assessment, you see that you have this was out of 20, an exam is out of 25. So it's essentially the same. Forgetting that in class I had said homework was 20%, exam was 75%, and so on. That is why I put homework 2 points now and make it clear that it's out of 400 points. So, and take home problem 5 points, and when you do 10, you give 50 points. It's not even up to one exam, which is 100. I hope you all understand that. I have to give 3 takes home or 2 before you take an exam, and the exam is 100 points. So this is to explain the fact that when your score are given with different weight, you can find the average by multiplying each score by the associated weight and divide by the total weight. Does that make some sense before I show you the formula? If you are having your score expressed in weight, you want to, so we will say that if your score is in weight, multiply each score by its weight and divide by the sum of the weight. Let me see if I have an example here, otherwise I will make up one. This is an example. Suppose your midterm score is 83 and your final score is 95. Using weight of 40% for midterm and 60% for the final exam, compute the weighted average of your score. So we are going to say that the weighted average will be 83 times 0.4 plus 95 times 0.6 divided by 0.4 plus 0.6 is 1. So it just happened that it is 1. Or you can say 40 times 60 and then divide by 100. The same thing, right? So then you will get the average score. So what is the average of this score? 90.2. So if A is above 90, then you will get an A. You use the weighted average. I think you might have a question on take-home problems. Suppose a student have the following score sheet. Cost, number of credit, grade. Let's just put grade points so that we don't have to make a lot. This is a student that registered for 4 courses. The first one maybe is Biology 101. And the number of credits here maybe is 4. And the grade, the student has a B, and we put 3 points. And then maybe Math 101. The credit here is 3, and the student has A. Then for 102, with a credit of 2, the student has an A, and will have 4 points. Then maybe 101, 4 credit, and the student has maybe a C, which is 2 points. What is the grade point average of the students? So we are going to multiply the grade point times the credit divided by the sum of the credit. So we do 4 times 3, plus 3 times 4, plus 2 times 4, plus 4 times 2. How many credits is it in total here? 13 credits. So this will be the grade point average. That is what you do to find the grade point average. So this is 12 plus 12, 24. 8 plus 8, 16. So what is the grade point average for this student? So this is a good example of weighted average when you use the grade point average. There is also a simple measure of central tendency, which is the mid-range. The mid-range is the average of the lowest and the highest score or data value. Sometimes it can be useful, especially when the scores are essentially the same. But if the score is too dispersed, we are going to learn about dispersion. Then we cannot use the mid-range. The mid-range is a rough idea of the mean. You add the lowest value to the highest value. Remember, the range was highest value minus lowest value. Mid-range is average of lowest and highest value. So we have learned about measures of central tendency. 3 of them are often used, and there is a 4th one, which is the mid-range. The mode, the median, and the mean. The mode is the most frequent value. The median is the middle of arranged data value. The mode is the arithmetic average, that is adding and divide by the total. We also spoke about trimmed mean. When we suspect outliers, we can trim the n to get rid of the outlier. We can also make use of the formula for weighted mean, which helps us to use the idea of weights with the score that we have to find the mean. So when we have the mean, and we want to use it now to assess how good we are, you want to know how far away you are from the mean. As the next question, how far are you away from the mean? Then another question that will come in is that, how are you going to determine the unit of that distance? Then we think about variations. That's why we call it measure of variations. The first and easiest variation is the range. Highest minus lowest value. We did that already. It's a rough idea about the variation. Now we get to what we call variance and standard deviation. So we all know what the mean is, and we want to determine how far away we are from the mean. What we will do is to determine the average deviation from the mean as our unit of measurement. Please don't write that. Just listen to it. Because if you write a lot, you might not know what is very important. Okay? If you feel like writing, write, but I don't encourage you to write everything I say, because you will have too many information and you might leave out the useful ones. So what I said, we are looking for kind of a unit, right? And what we want to do is that we want to think about the mean somewhere here and find how away is each value from the mean. That's what we will call a deviation. This will help you to know when they say standard deviation. Why do they call it standard deviation? So it tells you how away you are from the mean. If we know how away we are from the mean, we take the average of all the away from the mean of each of the values. We might have the unit of measurement of the distance from the mean. But when we try to do that, we face an issue, which is the fact that when you are adding the deviations, you will keep on getting 0. So deviation is x minus x bar. That's, I'm explaining. I don't ask you to do that with any time. I believe that if you know what it means, you will like it more. Not that right? Sometimes people don't like something because they don't know it. It's true that some people, that's not fair, right? If you don't know it, why you don't like it? But generally, that's how people are. If you know it, you might like it. So we have, this is the deviation, how the mean is away, how the point is away from the mean. If this is negative, it is below. If it is positive, it is above. Then, suppose I have 3 values, x1, x2, x3. Then the mean is x1 plus x2 plus x3, right? Divided by 3. Now, suppose I want the mean of the deviations. It will be x1 minus x bar plus x2 minus x bar plus x3 minus x bar. Let's say I divide this by 3. Let's me work the top part. Look at what I'm going to get. It will be x1 plus x3 plus x2 plus x3 minus 3 times x bar. Remember what x bar was? So do you see that when I will multiply this by x3, it will be x1 plus by 3, it will be x1 plus x2 plus x3. So I will do x1 plus x2 plus x3 minus x1 plus x2 plus x3. I'll get what? 0. So if we are attempting to find the average of the deviation, we will always get 0. So for that reason, statisticians felt like this is not very helpful. What we are going to do is that we are going to square the deviations. We are going to square the deviation from the mean, take the average of the square of the deviations, and then call it the variance. And when we take the square root of it, we call it the standard deviation. We square, then we take the square root, and we call it the standard deviation. So that gave us what we will call the population variance. Remember that the population mean is mu. The population variance is sigma square. We call this sigma square. And we say that sigma square is equal to sum of the square of the deviations from the mean divided by is the average of the square of the deviations from the mean. And the standard deviation is sigma equal to square root of sigma square. Now, when we get to sample, which is what we usually do in descriptive statistics, we are dealing with samples. When we get to samples, we are going to say that the variance of a sample is denoted by S squared. And we will do sum of the deviation from the mean divided by n minus 1. So we are a little bit careful here when we deal with sample because we divide by n minus 1. We are going to explain when we get to chapter 7 why we divide by n minus 1 instead of n. I will tell you, but you will not understand much about it. It's because we are looking for a statistic which, with an expectation, equals to the parameter. That is a statistic that when you use, you expect to get the parameter. So when we divide by n, it doesn't work. But when we divide by n minus 1, it works. And the difference is not very, very much. So for sample, this is the formula we use. And the standard deviation of the square root of the sample. We want to also observe that when we are using, we are manually doing this computation, we will find each value, find the mean, subtract the value from the mean, square it. Sometimes it's easier to use the formula. This guy is also equal to sum of the x squared minus sum of the x divided by n. So you can use this and divide by n minus 1. The same for this. This is mainly informative. I don't ask you to tell me about these things. But sometimes because you have seen it, it will be like you know it. No, that's just what I do sometimes, explaining some of those things. It will spice the knowledge in your brain, and your brain will like it, you know. That's how mathematics is. If you don't like it, you might not remember it. That's true for everything, right? So these are the formula that we use for computing the mean and the standard deviations. But as I told you, we are going to learn how to use Excel and the calculator. Anybody has calculator here? TR-83, 84? Good. So if you don't have, you will learn to use Excel for now. But I will encourage all of you, if you can get it, it will make work much easier. I don't assume that you are going to be doing this work manually. You will not have the time to finish the test. You're going to use either calculator or Excel. So these are just some few data values. Big Blossom Greenhouse was commissioned to develop an extra large rose for the Rosebud Parade. The random sample of blossom from hybrids A. Use the definition formula to find the sample variance and standard deviation. So, just look at what we are going to do. We list the data values, the sum. It will help us to find a mean. The sum of it is 36. Divided by 6, we get a mean of 6. That means we subtract it from each of the data value, and we get the numbers that are here. You see, these values were separated. We have 3 twice. So if you add these numbers, you will get 0. But if you had a frequency distribution, you would have had 3 and then frequency 2. So you have to think about that when you have a frequency table. Now we square the deviations and add it up to get 70. When we do that, the mean is 6, and the standard deviation for population, it will be 70 divided by 6, and for sample, it will be 70 divided by 5. Do we understand why the difference? Sample, you subtract 1 from the sample size. So we do 70 divided by 5 and get 14 as the sample variance. And then square root of 14 is the sample standard deviation. Now, we are going to use Excel or calculator. If you like Excel, yes. No, you get the standard deviation always from the variance. It's for the population that when we are computing the variance, we don't subtract 1. But population and sample, once you have the variance, the square root of the variance is the standard deviation. We get it. Most of the time, you will be dealing with sample. But in case somebody tells you that the value you have is from a population, you want to think that you want to remember that the formula for the population is slightly different from the formula for the sample. I am not sure in any of your homework. If you see it, remember it. I don't usually ask you to work with population, but I want you to know what it means. Actually, we don't know population. We don't know parameters. That's why we are doing statistics. If people knew parameters, they would not do statistics. Parameters is what we don't know, and with the real thing, but that we don't know. For example, the weather tomorrow, we don't know. Okay, so that is a parameter. So now, if you want to use Excel, you use Excel. If you want to use a calculator, you can use your calculator. If you are using Excel, this is a small size data. If you understand how to do for small, even if you have 1,000 values, you will do the same thing. If you are using calculator, press start on your calculator and then enter. And you will see L1, L2, L3. We are going to be using L1. So for those of you using Excel on column A, you can choose any column, but let's get used to using A. In column A, you enter the value 2. So these are our data values. When you have 1,000 of them, just enter all of them. A million of them, enter. So for the calculator, you will type, if you take your cursor to L1, type 2, enter, you will get to L1. Then type 3, enter. You will see 3 on the L1 line. Type 3, enter. You will see 2, 3, 3 on L1. Then type 8, enter. You see 2, 3, 3, 8 on your calculator. If you are having trouble with that, please let me know, because we want to learn how to use the calculator. It will be useful. This is the beginning. If you don't understand this little thing, I will come to show you. Sometimes it's easier to show you than to be speaking. So I cannot know if you are understanding or not. Please, if you don't know what I'm doing, just let me know. I will come to her. So for those, we want to do Excel first, then we will look at calculator. So we have data on Excel. Then you go to data. Then data analysis. If you're using Excel, you want to see this data analysis. And we will choose descriptive statistics. Descriptive statistics for now. And you press OK. The input range is your data values, A1 to A6. Highlight your data value, you will have the A1 to A6. I want my output to be on the same page, that's why I click here and here. And I will choose C3. And here you will see summary statistics. Summary statistics. When we get to chapter 7, you will click confidence level here to get that one. We don't need it for now. If you are using Excel and you have trouble, let me know. So now we just click OK. This was computation we have already done manually. And we are doing this just to know how to use Excel, especially when your data is complicated, decimal numbers and so on. So you can see that the mean was 6. Ignore this standard error. We are going to come back to it in chapter 7. The median is 5.5. The mode is 3. The standard deviation is 3.74 and the variance is 14. These are for the sample. Excel is doing sample. And we have all this information. We have the mean, the mode, the median, the range, and the mid-range. Mid-range, you just do minimum plus maximum divided by 2. Now, for those who are using calculator, you enter the data on L1. Make sure you see how to enter the data on L1. Then you press Start. Take your cursor to Calculation, Calc, to the right. After Edit is Calc. Take your cursor to Calc. And now press Enter. You will see one variable, statistics, 2 variable statistics. Choose one variable because we are dealing with one variable. Choose one variable and then press Enter. Do you see anything? So you will have a lot of information there. I want you to observe that you will have SX and sigma X. SX is the sample standard deviation. You don't have the variance on the calculator. To get the variance, you square that. If you are at the variance and you are using your calculator, what you get is the sample standard deviation. And you have the sample, the population standard deviation as well, which is sigma X. On the list of the values that you will see there will be 2 values, S and sigma. S is for sample, sigma is for population. So when you are using calculator, you have population standard deviation and sample standard deviation, but you don't have the variances. When you are using statistics, you have sample variance and sample standard deviation. You don't have population. So someplace you will lose something. That's what I want you to observe. But in each case, you can recover the other one. But as I told you, most of the time, at least for my class, it's about the sample I am dealing with. I deal with sample more than population. So using Excel will be fine. Any questions so far? That means as you are doing your homework, if you have your calculator, some homework problems, some homework problems will require the calculator. So if you don't have calculator, you can do it with Excel and get the basic one, but sometimes they will say, use your calculator to confirm that sum of x equals to sum of x squared equals to, and all that. Okay, I will not check if you use your calculator, right? So, but you want to see that on your calculator. You are seeing sum of x squared, all that are, when you do one variable, they give you all of those. But the aim of your book is for you to use that in the formula, that formula. But we are getting it, so I don't ask you for those questions, sum of x squared. But for your homework, you can practice doing that. If you don't have a calculator for now, no problem, just say I confirm, so I cannot verify it. So, yes. S, do you see SX there? That's the standard deviation. What do you have? Can you tell us what is that number? Right? That's the standard deviation. It's the sample standard deviation. And now, can you tell us what is the, since we are there, S is equal to, can you see here? S is equal to 3.74. So S squared is equal to 14. So suppose we are using this very data as a population. How will we get the population variance? We will remember that S squared was sum of the x minus x bar square over n minus 1. So if we have the sum of x minus x bar square, which is n minus 1 times s square, then this will be 14 times 5 equals to 70. And sigma square will be 70 over 6. Yes. Yeah, it will be 30.9 and other numbers. Yeah, so that is fine. That is the variance. If you square it now, because we cut it, right? It wasn't exactly 3.74. There were some other numbers there. So we cannot get 14 if we cut it. But we will remember that, okay, because of those numbers, we round it up to 7. But I don't ask you to find the population. I ask you for sample variance. Okay? If somebody asks you for population variance and you have sample variance, multiply your sample variance by n minus 1 and divide what you get by n, and you get the population. So, any other question? So this is section 3. Five minutes. I can teach coefficient of variation. So far, we have learned how to compute measure of central tendencies, mode, median, and mean. Measure of variation, variance, and standard deviation. You can do that with Excel. You can do that with your calculator. What are the use of the variance and standard deviation, or the standard deviation? It tells us the variability of the data. So the higher the standard deviation, the more the distribution varies. Okay, so the standard deviation is a measure of variation that helps us to determine if the distribution varies more than another distribution. So if you have a sample and S equals to 370.74, sample 1, and sample 2, S equals to 2.46, then you will say samples. This distribution varies more than that. Do we get what I'm saying here? The standard deviation is used to determine the level of variability of the distribution. But sometimes we get into trouble with unit. Unit is always going to come back. Suppose I have a distribution with the unit in hundreds, another distribution with the unit in tens. Then the standard deviation naturally of the distribution in 100 will be in 100, and the standard deviation of the distribution in 10 is going to be in tens. We can't compare those two to make a decision because they did not have the same unit in the first place. So what we will do is to find the coefficient of variation. The coefficient of variation is equal to standard deviation divided by sample mean times 100%. This is for sample. And for population, it's equal to sigma divided by mean times 100%. Once you find the coefficient of variation, you can compare any two distributions. Example. The trading post on Grand Mesa is a small family-run store in a remote part of Colorado. The Grand Mesa region contains many good fishing lakes, so the trading post sells spinners. The store has a very limited selection of spinners. In fact, the trading post has only 8 different types of spinners for sale. The prices in dollars are what we have here. Since the trading post has only 8 different kinds of spinners for sale, we consider the 8 data values as the population. So this is just an example to practice. You might see some in the book, but I don't deal with population in most of the work I give you, so that you don't get confused about those two. If you understand everything about sample, you will understand with population. It's the same thing. Just that sometimes the formula will slightly differ, like for the variance. Use a calculator or an approximate statistics to verify that we have this. So why not check with your calculator with this data? Use your calculator or use your calculator. If you don't have, use Excel. Put it on L1. Okay, to put on L1, you can either start from put the cursor on the first value, enter this first value, it will replace the first value you have. But you can also clear the line. Let's just learn how to clear the line. To clear the line, take your cursor until you reach L1. L1 is on top. So move out of the dot, get to L1. Press enter. I'm sorry. That's clear. You will see clear somewhere. Once the cursor is on L1, press clear and press down. So that is how you clear, so that you don't mix things up. Always clear it if you want to enter new data. Yes. Okay. So it's A11 to A18. Now, that's the question. Anyone use cards? So, if you are using your calculator, can you tell me what sigma is? Anyone using calculator, what is sigma? Those with calculator can have sigma. Somebody with calculator, tell me what you have. Let's just leave it this way. Let's round up to 2 decimals. The values had 2 decimals. We should round up to 3. It's fine. You said 2.17 and then 3. Okay, let's leave it like that. You rounding up here, just round up to 1 decimal more than the data value. I get what else? Yes. It is in? No, it doesn't matter. If it was like in hundreds of dollars, that will matter when we are rounding up, because it's 1 unit. So now, because these data values have 2 decimals, we will round it up to the 10th decimal. Now that makes some sense. Yes. Yes. Divided by the mean. So what is the mean? 2.14. So the coefficient of variation will be 0.217 divided by 2.14 times 100%. So those of you using Excel, can you tell us what was the sample standard deviation? What is the sample standard deviation, if anyone has used Excel? 0.232. And then the sample mean, 2.14. Mean is the same. So we are going to do, the coefficient of variation will be 0.232 over 2.1. So let's save the rest for Tuesday. Okay. So you might not be able, if you want to do the homework, you can go over the PowerPoint or wait for Tuesday. We will complete everything on Tuesday. I don't want to put too many information. Please sanitize before you leave. As I am reading attendance, pay attention. Rhoda, Madison, Jacqueline, Megan, Macy, Caroline, Polly, Tiffany, Victoria, Marisa. Marisa? Yes, thank you. Molly? Gabriel? Shannon? Julia? Nicole? Madeline? Emily? Thank you.
So why did we divide these two?
To find the coefficient of variation,
Okay.
you divide the standard deviation by the mean and multiply by 100.
Okay. So mu is mean.
Okay.
Mu
is mean. Mean,
okay.
mu.
Okay. Okay, thank you.
You're welcome.